Hello and welcome to another episode of Zap Chat with myself, Simon and Yanis.
Hello.
Great. So last week we covered the spiders, both the traditional spider and the Ajax spider. So hopefully today we're going to get onto ActiveScan, but before we do that, we've got a couple of little jobs. Now, one of them I already mentioned, which was the passive scan wait.
Mhm.
But I'm going to demo it this time just so you can see why you really want to use it. So let's share my screen.
While you do that, Simon, just to say that a delay job is one of the one of the easiest actually jobs to implement in often distinguishing between tasks that each job runs.
Yeah,
Not only does it give you the opportunity to, let a previous job finish and complete and so on and so forth, but also it just gives you that sanity check that everything up until that point has run according to plan, right? Because it is a set of jobs that are part of a plan. So very important to incorporate delays in your overall strategy when it comes to automation.
exactly. So what I'm going to do is I'm going to switch to the automation tab because we're still on the automation framework, and I'm going to create a new plan. And what we're going to do is we're going to run the spider. And I'm going to run the report. So we're not going to go into the report in detail, but I want to show you something. So to start with, we have to actually put a URL in.
What are we scanning this week?
Oh, I'm going to go back to budget. It's just nice and easy.
Good call.
So localhost budget, and we're just going to spider it, and then we're going to run the report. And the report I'm going to use is the traditional PDF report. And for demoing purposes, I'm going to display the report. This may come up on my other screen, and I'll just have to move it across. But let's run that and see what happens. So the spider should be pretty quick. And there's the report. And actually, this one did come up with some alerts, which is not what I expected.
Oh,
um,
we're mainly low risk and informational, right? Oh no, there's three mediums as well.
yeah, so I tried this just now. Let me try that again to see if we get anything different or whether it's going to just kind of mess it up. That's better. That's what I was expecting. So this is a timing thing. So basically, ran the spider and generated a report. The first time, as you saw, we did actually get some alerts. This time we've got none at all. So why did that happen? What happens is we're getting alerts from passive scanning. So passive scanning happens in the background,
Mhm.
and we have a set of background threads. And so the spider is completely independent. The spider goes ahead, does its job, explores budget, finishes, we run the report job, and then it's kind of a timing thing. How far has a passive scanner got? First time, it found a few things before we ran the report. The second time, it hadn't had a chance to get started. So this is why you need a delay job. Now, we've got a generic delay job, but we also have a very specific one, which we have talked about before and demoed before. And so that is the passive scan wait. So I'll add that. And you see it's just got one parameter, which is a max duration. If you leave it at 0, it'll wait until the passive scan is finished. But if you've got a particularly large site and you want to make sure it finishes in a certain period of time, you might want to set that. So this is in minutes. You might say, okay, we just want to wait for a minute, 5 minutes, whatever you want. But if you finish the passive scan wait before the passive scan is finished, you might miss out on some alerts, as happened. Now, it
But
also,
Simon, why are
yeah.
we adding a so what's the advantage of adding the passive scan wait versus a traditional delay job?
So in this case, we know when the passive scan will finish. So so say we got a max duration of 1 minute. Well, if the passive scanner finished before then and we used a traditional delay job, then we'd still wait for that minute. Whereas in this case, it'll take a few seconds. So let's run this. I will just clear the session again. So we're starting from scratch. We've got no alerts
Mhm.
down here. Run that.
And just for our new listeners and viewers, you don't have to clear the session every time. We're doing that so that you see a clean log and sequence of events. So
Exactly.
here's the report.
Yep. So we found the medium low informational, and we have a look down here. The passive scan wait took 2 seconds. So we'd put a delay in for a minute. We'd be waiting for a minute with no reason.
So that's the advantage for our listeners, right?
Yep.
So the passive scan waits for the passive scan to complete, while otherwise with a delay job, you would be guessing seconds or minutes or whatever the time period might be.
Exactly. Now, there are two reasons that I can think of why you want the passive scan wait. The traditional one is before you run the report, so that we know that the passive scanner has finished and picked up all of the alerts, passive scan
Yeah.
alerts. The other one we did cover in the last session with the spiders, because we've got a special alert for detecting modern web apps. And so if you actually want to use the traditional spider and then only use the Ajax spider if the traditional spider spots as a modern web app, then you'll also need the passive scan wait in between those two spiders.
Why do you need the passive scan wait between those two spiders?
Because it's a passive scan which detects whether something is a modern web app or not. So again,
Right.
if you ran the traditional spider, we still might have not gone through all of the passive scan might not have finished. It might have detected it's a modern web app. We'll go, it's not modern, we'll carry on. When in fact it is, we just need to wait for that passive scan to finish.
But you need to let the passive scan complete in order for the report to be generated correctly for the finding that a modern web app has been, spotted here. And if you don't do that, you risk having, the same way that here we've got the passive scan wait, you risk having the spider complete, but then you haven't completed running all the passive scan rules against that rule set. So that's why you need the passive scan wait for in between spidering and also in between spidering and reporting in this case.
Exactly. So that's the passive scan wait, but we do have another option. So let me just get rid of some of these because we don't want to show, we don't need any of these. And we don't even need the spider because what we're going to show is the delay job. So that's down here. Now, I'll start off just by running it, showing. So you've got an option, you've got either time or file name. I'm going to just leave it blank and run it, and we'll see it does nothing. So
What's the difference between time and file name?
let's have a look. So let's put a delay, or we'll put timer 5. Now, it's not a spinner. You can put anything you like in here, but the format expected is actually hours, colon, minutes, colon, seconds. So you can put that in, or you can put that in. So 5-second delay, and let's run that. And we'll see it's running 2, 3, 4.
5, there we are. Okay.
Now, then let's have a look at the file. So I'm gonna clear that. And what I'll do is the file I'm gonna put in is this one. So actually just switch to the terminal and file not found. Great. So I'm gonna save that and I'm gonna run. And that shouldn't have happened.
I think that the main point that you were trying to display here was that if you point to a file that does not exist, then by default, of course, the delay is going to be invalid, right? That's not going to be functioning correctly.
Yeah, the delay. Thank you for pointing that out. Basically, we need a time in there. So it's whichever of these happens first. So if I just put in the 5-second there and it's kind of chooses either. So we'll wait for 5 seconds and then that will finish. So what I wanted to do, what I should have meant to do, was put in 5 hours. So that will then, well, it doesn't, I don't think that matters. If we run that, then that's just going to sit there. So
It's going to be a long video.
it's going to be a long video. I think we're going to run out of time on Zoom. So what I can do is we go back to the terminal. So we saw that the file, oh, LD, I meant LS, would have helped. That file doesn't exist. What I'm going to do now is I am just going to touch it. And for those of you who don't know Linux commands, this will just create an empty file, call that name. And you keep an eye on the running task, and then you'll see it finishes. So what this means is we can run the task, this delay job, until that file exists. Now, why would you want to do this? Well, the standard use case we're thinking of is where you have a set of unit tests that explore your application thoroughly or fairly well, and they actually use a browser or the network tests. So integration tests typically. What you can do is you can proxy these through ZAP. And this is a really great way of helping ZAP explore your application effectively. Because often, if you've got a good set of integration tests, then you'll have good data in there. The better data ZAP has, the better ZAP can explore the application and the better ZAP can test it. But if you're running that integration tests, those will be run completely outside of ZAP. So ZAP doesn't know how long they're running for. And this is what the delayer's job is for. So you can say, okay, it's going to take 20 minutes to run the tests. We'll put a delay in for 20 minutes or 25 minutes just to be safe. But sometimes, you don't know exactly how long. So you could say, okay, we will then create a file after the tests run. Then you don't have to worry about delaying for a certain time. You go, okay, run the tests, create a file, something that ZAP can access, and then it'll be fine. However, we've got some other options as well. So what I'll do is switch to zaproxy.org, and we go to documentation, and we then have automate and the automation framework. And we scroll down, you can see all of the jobs here, and we're building up that set of videos that we're recording now. And then we got the delay job, and you'll see it's got those parameters, so it explains about the time, but it also says there's a couple of other options. So we can either call a static method or we can call the API endpoint. While I'm here, I will just run this again, and we'll see it finishes really quickly, and that's because the file still exists. So I'm just going to take that file off, and we will then run it, and it's not going to finish for 5 hours, which,
Yeah.
well, so let's have a look at these options. One of them is a static method. Now, that is something that we can call within ZAP. So if we go into scripts, and we will cover scripts in more detail another time. So I can create a new script and delay, and we will use, Graal. I'm not going to use a template. It's a standalone script. And what I need to do is call this method,
Name. Yeah.
copy and paste. And once again, so have a look down here. We can see the delay job is still running. And there you go, it's finished. So we can call that directly, but that you've got to actually be within ZAP to be able to do that. So let's switch back, and we see we can call an API endpoint as well. So let's kick this off again and paused, and we now go to the browser and we point the browser at ZAP. Then this is the default page you'll get if you point at the host and port that ZAP is listening on. Got a local API. And so this is a UI which allows us to just navigate around, automation, and we've got this end delay job. Now, I've turned off the API key to make it easy, and I'm in a safer environment. If you're not in a safer environment, then you want to set an API key and you want to provide it.
You have an API key, right? Absolutely.
Yeah. But we have a look here. So that job is running, and we run the end API job, and you'll see it's finished. So that means we've got an option for pausing the ZAP plan while you're doing other things. Typically, proxying stuff through your application to help ZAP explore it more, more thoroughly. And then you can finish the job and carry on with a plan. And you've got the option of just using a pure timer-based thing. You can use a file name. You can use a ZAP API call, internal call, or a ZAP API call. And if you can think of anything else that we should support and we don't, let us know. We can add these things.
It's a really good set of options. And what I like about this is that it demonstrates how dynamic automation actually is, right? Because you're relying on another file to be created, or you're relying on an API call to terminate something that's going to take 5 hours to run. So it's really good to see all those options come together on the excuse of just, a passive scan wait and how to best evolve that in the context of automation.
Exactly. Cool. So now what we're going to cover is the activeScan job. So this is where we're actually going to attack things. So I'm going to carry on using budget. And what I'm going to do, I've got rid of the delay jobs because we're not interested in those. And I'm just going to add the activeScan job, which is right towards the end. And you'll see it's got quite a few options, but I'm just going to use it like that. And we will start a new session. So we've got no alerts down here. And I will run that. And it finishes really quickly. And it finds nothing. Now, this is because we have a kind of separation of duties. The activeScan job and the activeScanner only attacks things. It doesn't do exploring at all. We've already covered all the different exploring options we've got in previous videos. So we've got, we can import APIs, we can run the spiders. We've talked about proxying tests through ZAP. That is how you explore your application. You've got lots of options, and you have to explore it before you can actually attack it. So running the activeScan job on its own will do nothing. So in order to demo it, we will actually have to explore. And because we're just using budget, we can use the traditional spider. Now you'll see that we automatically put that when you add jobs, we automatically put them where we think they're going to be useful. In this case, it's right. But say you're adding the passiveScan-wait job, and you want it between the two spiders, you have to move it yourself. Now, I'm not going to run it like this because it'll take a while, and you don't really need to watch to see it. It's sitting there spinning. So what I'm going to do is talk about the options that we've got with the activeScan job. Now, we only have one context at the moment, and we don't have any authenticated users. As I've mentioned, we're going to cover those in a future video. The policy, we can actually have scan policies. So you can define policies which cover different sets of rules. And I wasn't going to demo those now, but I will show how you can actually change the default policy. But you can, within ZAP, you can define your own policies, which say only look for cross-site scripting or something like that.
Only look for SQL injection, only look for cross-site
Exactly.
scripting and SQL injection, right?
Yeah.
That's where the default policy needs to be overridden for only a set of rules to be included as part of your custom policy.
And, so if you're doing a scheduled scan once a week or overnight, you might want to have most of the rules enabled. But if you're doing a scan as part of CI/CD, you might say, okay, I only want cross-site scripting or something like that enabled. You might want to tie it down very tightly so that it runs much more quickly. So we have an option here for the maximum time any one particular rule will run in minutes. And then we have the maximum time that the whole scan will take. So these are separate things, and these are all options that are standard within ZAP if you're using it as a desktop tool. And we've got the maximum number of alerts per rule. Now, this is quite useful if you're actually scanning a large application. And say you've got, say you're missing a particular header. If you're missing a header, security header on all of the pages, you could get tens, hundreds, thousands of alerts potentially. So what you can do is you can actually say, I only want 10 alerts. If you know that, well, you're going to get a certain number of alerts, and after that, it makes no difference. If you know that they're missing on most of your web pages, the security headers, you don't need an alert for every single one. And what the maximum alerts per rule means is that after, say we set that to 10, then after we found 10 alerts for a particular rule, we will stop that rule running. So this will speed up your scan. But I'm also going to, we also have default thresholds and strengths. So the threshold is the level at which the scan rules report potential vulnerabilities. If you've got a low threshold, this means the rules are more likely to report vulnerabilities. If you've got a high threshold, it means they're less likely to report them. So putting it low means you probably get more alerts, and putting it high means you probably get less alerts. Now, normally we would assume most people would keep the default threshold on medium, except unless you want to actually turn all the rules off by default, and that's how you can do it via the threshold. So this is a kind of you can change the threshold, say, okay, we want more type of alerts or less. Maybe you want to have the high threshold because it's automation. You want to make sure that your developers just see things which are much more likely to happen. But the other option is turning everything off. Then you can turn specific rules on.
So when it comes to threshold, I often parallelize threshold with, the indicative first initial risk that a rule has, right? So for example, SQL injection, where you enter a tick character and you get a SQL error back, that would typically fall in the default threshold of high, right? Because it's very likely that indeed you have some sort of SQL breaking at the back end. It might not be completely injectable, it might be blind, etc. But there's something going on which is a high risk regarding the web app or API endpoint or whatever
Exactly.
that you're attacking. Now, with that in mind, what strength? How do we define strength in the context of the default policy?
So both thresholds and strength are actually per rule. And these are then the default policy applies to all of the rules you're running. And by default, ZAP will run the active scanner will run all of the rules you've got installed. So, and the strength is very much, it kind of comes down to how many requests ZAP sends or how many requests the rule sends. So the kind of finger in the air we have is with a low strength, we will aim to send at most about half a dozen requests per parameter per page. So that it doesn't sound like very many, but that builds up pretty quickly over a larger web application.
That, right? And
exactly. So medium is around a dozen, so around 10 to 12, and not all rules will do this. So for something like cross-site scripting, what we do is we send a safe value first, and we see whether it's reflected anywhere in the page. And if it's not, we try something else. But generally, cross-site scripting will only send a few initial payloads, and will then carry on. Even if you put it on really high strength, it'll only do a couple of payloads, and if it doesn't find anything reflected, it will carry on. But it's very much specific to each individual rule. So your medium is around 10 to 12, high 20 to 24. And then we've got an insane level. And the insane level basically says the rule can send as many requests it like. It could be hundreds. And in a couple of cases, I think it is hundreds. So we don't expect people to use insane strength for all rules on a large application. It will just take too long.
It would take too long. Yeah.
So
Absolutely.
it's much more, this is for manual pen testing. You found one particular page and you're really suspicious about it. You haven't been able to tie down exactly. Put it on insane strength on one particular rule, hammer it and see, have a really good go. But in this case, I'll leave it on medium. And this means, again, the active scan job will do nothing at all because I've turned the default rules off. So we've got policy rules, and this is where we can have exceptions to the default policy. And so what I'm going to do is we can add any rule we like, and I'll go for cross-site scripting reflective. And you can see the threshold by default is off, which won't help, unless, of course, the default threshold is on, in which case you will want to turn particular rules off potentially. So I'm going to change that to medium, and that means we have one rule set on medium. Everything else is off, and I've not specified. Well, I've got 10 at maximum of 10 alerts, but that shouldn't matter. And we'll now run that, and you see the spider finishes pretty quickly. And there we go. The active scanner has finished, and we do actually have a
The findings, yeah.
cross-site scripting, and that looks pretty convincing to me. And you'll
Yeah,
see
that's additional exercise on the search page, right?
yeah. So that is the active scan job. Now, basically, if you have, you can choose to whichever policy you like, but we've also got some advanced options as well, which I'll just go through very quickly. We have a delay in milliseconds. Now, usually we have this complaint that tools like ZAP take too long when doing active scanning. Well, sometimes it's too quick and it actually hammers web applications. We've had lots of cases where either web applications fall over, or if you've got some sort of firewall in there detecting things coming in too quickly and then blocking the scanner. So you
Throttling, yeah.
yeah, so we can actually put a delay in milliseconds for in between every request that ZAP sends. So this will slow ZAP down and might mean um, your application actually stays up, or that the firewall doesn't kick in. We also have the number of threads per host. Now this defaults to the number of cores, so I've got 16. This will speed things up, but it will also put more strain on your system. You can shift up to 32, will be quicker, but whether the host or the box running ZAP might struggle then, or we can drop the number of threads down, but then that will take longer. Then we have a few.
Generally, a safe option on threads is to go up in not powers of two, right? Because 16, 32, 64, 128, that's a large thread pool. So
Yeah,
you tend to go up in increments of two instead of the power of two. And of course, always test 16 threads per host per rule is a lot, right, by default as well. So 32 is twice that. Maybe you need a value somewhere in between, and it's best to test these things out instead of just guessing and multiplying the value exponentially.
exactly. Now we have the active scanners, lots of options. We've just exposed a few of them by the automation framework job, the ones we think are most useful. There's an option to add a query parameter, handles anti-CSRF tokens, which I think we do by default. Um, Inject a plugin ID. So this actually injects a header saying which rule is running. So you could actually use this as a way of detecting what caused problems on the back end or something like that. You'd tie it in with the logs or something like that. And we've got an option to scan all headers. By default, we just attack a small set of headers. You may want to actually, if you really want to do a thorough test, scan all headers, but this will take longer. There's always a balance of what do you actually attack versus how long things take. The more you attack, the longer it'll take, the more chances of you actually finding potential vulnerabilities.
Just one last comment on injecting plugin IDs from me. Very useful if you know that you're up against a WAF and you want to make sure that you are actually bypassing that. So when you've got the opportunity, you can enter the plugin ID regex. And we've got those in the documentation pages. And what does that mean? It means that you're not testing whether or not the WAF is actually doing its job, but you're testing it, the application can stand up to scrutiny, and you're allowing those plugin headers to go through because they're whitelisted on the web application firewall.
Exactly. Or if you say you want a particular key to get through the firewall, and maybe that's how the
Or
file is configured,
yeah,
then in that case, we'd use the replacer job to actually add one specific header
right,
to all requests. So we've got
yeah.
a range of options. And so we can do a replacer job, or if you need to do something more sophisticated, then you could actually add a script, which is also supported by the automation framework, and that we'll cover in a future episode.
There you go. Yes, indeed. We've got the replacer job. That's good inspiration for the next video.
We've done the replacer job already. So
For a bigger scope, right? Not just here's the
yeah,
replacement
well,
job.
scripts are definitely up there. Have to work out what we haven't done the reports job yet. But
Ah, yes, that's it.
we've done most of the standard ones, but have to go through. But there's still, yeah, scripting and authentication. So those are a couple of big ones, which whether we'll do them all in
Coming up
each
your
of those
way.
in one session, I don't know, but we'll see how we get on. So that's everything for this episode. If you like these videos, then please like them on YouTube and subscribe and add comments saying what else you'd like us to cover. Thank you very much, and until next time.
Bye now.